We're now going to talk about continuous probability distributions. So this is different than discrete probability distributions, which we have done at a different time. So as a reminder, a continuous variable is one that can be any value within a range. So for example, the weight of a hippo, maybe it could be between 200 to 5,000 kilograms, but it could be any value in that range. It could be, for example, 712.3122 kilograms. Length of a hair also could be any number within a range. So both of these would be continuous variables. Number of hippos in a zoo would not be a continuous variable because let's say the range is that there's anywhere from 0 to 27 hippos in the zoo. We can't have 11.33 hippos because that just would not make sense. So let's look at a continuous variable. So I say the length of a hair can be between 50 and 90 centimeters. What is the probability that a random hair has a length of 82? So we know that the hair can be between 50 and 90. And we want to know what is the probability that the hair is exactly 82 centimeters. So what we have to do is we have to think about how many numbers there are between 50 and 90. So between 50 and 90, we actually have, well, we have 50, 50.1, 50.01, 50.0112, 50.0113, 50.000012. We actually have millions, billions, trillions. There's actually an infinite number of numbers between 50 and 90. There's an infinite number of numbers between 50 and 90. And I want to know what's the probability of being exactly 82. And so the probability that x is 82, so there's one way for it to be 82, which is 82, and there's infinitely many other answers, and 1 divided by infinity is 0. So the probability that a hair is exactly 82 centimeters is actually 0. And that's true for any value. There's nothing special about 82. The probability of it being 81 is 0. The probability of it being 73.2 is also 0. So the probability of it being a specific number is 0. So with continuous variables, we're not going to talk about the probabilities of something being an exact number, because that won't be interesting. The way we're going to show continuous probabilities is we're going to generally describe probabilities as equations. And they're going to be called probability density equations. And they might look something like this. So, for example, maybe this is the hairs, and the y-axis is something called probability density. And the idea is that the area under the graph, so this area over here, totals 100%. Now let's say let's say I say, what's the probability? Let's say I wanted to know the probability that x equals 62. Well, the area of a line, assuming it's infinitely small, is 0. So that's not very interesting. But let's say instead I said, okay, what is the probability that x is between 62 and 64? So what I would do there is, that's 62, that's 64. And then this over here is the area under the curve for that. Well, that does not look very pretty, but. And so this area, I'm not sure what it is, and it's obviously relatively difficult to calculate, but that is not 0. It's an actual number. So when we have distributions, we're going to have, we can't figure out, there's no probability of a given number, but we could definitely find the probability of a range.